This video is very much for the desktop CNC enthusiast. William Bond, the great 19th century American clockmaker, used spring-tensioned inertial flywheels for many of his clocks. This picture shows a few of the parts used on the remontoire of my clock, and in the foreground you can see the spring-loaded inertial flywheel, which I'm now going to show you how I made on the Carvera Air desktop CNC. This is a prototype inertial flywheel. I've just been experimenting with various springs to get the right tension. And it requires a really small and known amount of friction, so that when the arbor turns, the inertial flywheel will turn as well, and when it stops, there's the correct amount of run on, so it releases the energy. And you can see I'm turning it, and I stop, and it just runs on a bit. And to get the right amount of friction, first off I've added a ball bearing to reduce the friction to virtually zero, and then applied a spring which is the tension of which is adjustable, and the spring bears against the arbor. So anyway, this is the prototype, and I'm going to now make the final version on the CNC. I found that one of the best ways to machine on the Carvera Air is to use the decorator's tape and superglue method for sticking your components down to the bed. So I've machined this aluminium plate, which is pretty flat, and using the dowel pins in the Carvera bed, I've located it and screwed it down, and then I've drilled a hole for a dowel pin. This hole is actually drilled at 150 by 100 from anchor 1, so this will become my known center location. That way I can fairly easily turn parts upside down to machine them if I need to do a two-sided machining. So I cut a blank out of a 3 1/8 inch thick brass plate. I've applied super glue to the back side of it on top of decorator's tape, and then now I'm going to put it on the mandrel and the dowel pin rather, and stick it down to the base plate. And I'll put a weight on that and leave it to go off for 10 minutes or so. So this is the part that I've designed on Fusion. And I'm going to do the cam on Fusion. So if I go to the manufacture package, you see I've already set it out on Fusion. I've given it some stock to work with, and the first operation is a boring operation. The second operation, these two drill holes these are the spring mounts and the adjustable set screw. Then I've done these 6 contours, and then I finish off the sharp corners with a 1.5mm cutter. And actually I may do one more derived operation. Let's do that now. Do a derived contour operation, and we will finish it finally with a 1mm cutter. And if I go to rest machine, put in the previous size cutter, which was 1.5mm. Now we've got a final operation, which should give us really quite sharp corners. So now I'm going to post that file, and we'll call it Flywheel. And now I will open up the Cavera software and import the file and carry out the machining. So I'm now in the Carvera machining software, and I'm going to open my file from Fusion, which I call Flywheel. and then I'm going to set up the origin parameters, and it's at 150 by 100 from the anchor 1, and I'm going to scan the margin just to be sure. So I've decided to auto Z probe in just one point, which I'll do somewhere near the center. I couldn't use the 3x3 configuration because it picks up a central point, and that's where my dowel pin is. I've actually asked Cavera how to eliminate it picking up on the central point so that I could use the auto leveling feature, but this should be fine for this project. I've loaded the auto Z probe and we're ready to start running the program. So I'm going to start with a 2.5mm drill to drill the 2 holes. Then I'm going to put in the 3mm cutter, and we will cut all the main profiles, and then I'm going to mill out the corners, the sharp corners, using first a 1.5mm cutter and then a 1mm cutter. And I won't show you all the cutting because it's pretty dull watching it, but I'll probably switch on the camera at various stages through the cutting process. So in with the 2.5mm drill. Okay, we're peck drilling these two 2.5mm holes. So I've now put in the 3mm cutter, and we are going to carry out the boring operation for the bearing mounting point. I want a really accurate location for the bearing, so I'm using several finishing passes and leaving it 0.05mm oversized. So it looks like we are just finishing the last of the pockets, and then it will go on to cut the outer profile. So we're about 40 minutes into the cutting now, and we're just doing the outer profile. So the main machining is now finished, and I'm just going to sharpen up the corners of the spokes. So say when I've gone in with a 3mm cutter, the corners show up the radius. So I'm going to go in and clean it up with a 1.5mm cutter, and then I will clean them up with a 1mm cutter, so they should get quite sharp looking. So that's sharpened up some of the spoke corners quite a lot. I'm now going to try and finish off with a 1mm cutter, which seems truly tiny, and I'll probably end up breaking it, but if not, well, it should end up with really sharp spokes. So here's our little 1mm cutter. So the 1mm cutter is just doing the sharpest of the corners at the moment, so if it's going to break, this is the moment. So that's a result. The 1mm cutter didn't break. So now I can take this part off the base using the hot air gun, and I'll clean it up on the lathe, and we'll come back and see what it looks like. So here is the finished flywheel. I've just cleaned it up, spun it up on the lathe, and used some emery cloth to shine it up a bit. I've added a bearing and a spring attachment point here and a spring adjustment point here. You can just, I think you can just see the spring, which acts on the axle. So if I now spin it, you'll see that there's enough grip to make it spin in the first place, and there's just a tiny bit of run on, so it releases the energy. So that is the finished part. Next I'll show it installed on the clock and working.